Well, hey everybody, Mr. Reeves back with you, and in this video we're looking at writing and solving one-step inequalities. For those of you following along at home, this is lesson 7.1 in the Accelerated Math 7 textbook, page 203. But we're actually going to deviate away from this just for a moment. All right, so let's go back and remind ourselves of what an inequality is. We've spent a long time working on solving equations. Remember, an equation was when you had one expression set equal to either a constant or an expression set equal to another expression. Well, an inequality, all right, we could almost call it an inequation. In meaning not, all right. Inequality literally means not equal. All right, so inequalities, as it says right here, show the relation between two expressions that are not equal. Not equal. And of course, we're starting right off here with just a constant. This says 9. And let's take a quick look and remind ourselves about these symbols here. All right, that symbol right there, greater than. All right, notice the larger part comes first, greater than. This one is greater than or equal to, right? So that little line there, it's part of an equal sign, greater than or equal to. This one is less than, and this one is less than or equal to, right? So this statement right here says 9 is greater than 7. This says 6 is less than or equal to a plus 2, and this says x is less than 5. All right, so again, those are the symbols, but one of the things you should know is there are many other words that we use besides greater than or equal to, less than or equal to, and these are ones that you're going to want to familiarize yourself with because you are going to be asked to not just solve them, but to write them. So I've got this site right here that has a whole bunch of them. All right, so let's just start first by looking for words that mean greater than. All right, so again, this one is greater than. That symbol is greater than. All right, so if we take a look here we go, greater than. So more than is one symbol, one phrase that means greater than. As we go down, above, that also means greater than. Let's see any more. More than also means greater than. All right, any more that they have on here that means greater than. Well, that's all they have that for greater than. Let's go to a different color here. So now let's go to greater than or equal to. Now remember, greater than literally means that it cannot be included. So if I were to ask you, is 3 greater than 3, the answer would be no. All right, greater than or equal to, on the other hand, it can be included. So if I asked you, is 3 greater than or equal to 3? Well, 3 is not greater than 3, but it is equal to. So greater than or equal to. Here we go, minimum. All right, if it has to be a minimum, that means greater than or equal to. All right, exceeds. All right, greater than or equal to. Actually, you know what? I would disagree with that. If it exceeds something, I would say that actually that would be, I'm going to disagree with the author here. I'm going to say exceeds, because if you exceed something, you are greater than that. So I'm sorry, but I'm going to have to disagree. Exceeds means greater than, all right? Sorry, this is greater than, and this is greater than. Okay, let's go back to greater than or equal to. At least, all right? If you have at least $10, you can have $10 or more. That one I agree with. All right, greater than or equal to, any or right here. More than or equal to. You notice we can just substitute more for greater and we get that same thing. All right, not below. If it's not below $10, then it's $10 or more. All right, no less than, or sometimes we have not less than. All right, that also means greater than or equal to. All right, any more that I missed? I don't think so. All right, what about less than? What about less than? What are some phrases or other words that we use for less than? Smaller than. Smaller than. All right. Let's see. Any more just pure less than? Below is another thing for less than. Any other less thans that are on here? All right. Smaller than, below. All right. Okay. What about our last one? Let's see here. Let's get a different color other than black. How about magenta? I like magenta. So less than or equal to. Okay, and remember, something cannot be less than itself. So if we go back to 3, 3 is not less than 3, but 3 is less than or equal to. Remember that equal to. You can't be less than and equal to, but you can be less than or equal to. All right, less than or equal to means less than or equal to. I'm not going to do that one. Maximum. Okay, if you have a maximum of $10, then you have $10 or less than $10. Not to exceed $10. That's also a less than or equal to. At most. All right, you'll notice at most and at least are opposites, right? At most and at least. All right? No more than also means less than or equal to. Okay, so these are some good phrases that it would be good for you to know and recognize because you're going to see them in words when you're asked to write inequalities. So familiarize yourself with these terms. All right. Okay, so let's go back to where we were here. So there are those symbols: greater than or equal to, less than or equal to, less than or equal to. All right, now one thing that's different with inequalities, well, one of the things that is different with inequalities is we often use number lines to show our answers, because for most of the equations we solve, we just got one solution, right? Now we did have that exception at the end where we had infinite solutions, right, or no solutions, but most of the time for our equations we were just getting one answer. Well, inequalities usually are going to have infinitely many answers. So we often graph them, and if it's one variable, we graph it on a number line. So if we take a look at x is greater than 4, if I asked you to tell me what are some numbers that are greater than 4, probably the first answer I would get would be 5, right? Or 6 or 10 or 12 or 100. But don't forget they can be fractions or decimals too. You could have 4.1 or 4.0001. Anything that is bigger than 4. So on a number line, this is what it looks like. All right. We have our number line here. All right. You'll notice that all these values over here are greater than 4. And then right here we have an open circle. All right, that open circle indicates that 4 is not included, but it's the boundary. All right, it's the boundary. I often refer to this like a fence between 2 yards, okay? It's actually, all right, it's not in either yard, correct? It's that fence. That open circle is like a fence. All the values to the right are greater. All the values to the left are less. And that open circle represents the equal part, but there's no equal on here, so it's not included. So x is greater than 4. All right, what about another one? Y is less than or equal to 3. Now notice this time there's 2 differences. Well, there's more than 2. We've got y instead of x. But instead of greater, we've got less than or equal to, and we've got 3. So now I want all the values that are less than 3 or equal to 3. So if we go down to this number line right here, you can see there's my 3, but now that's included. All right, it's kind of like you built the fence on your side of the yard, so you own the fence. All right, so it's less than or equal to. And notice less than values. If I said what are some values less than 3, again 2 would probably be the first one, and then 1, and all these negatives are less than 3. But don't forget, anywhere in between here, like 2.5, right, or 2.9999999, those are all less than 3. Okay. All right, so let me do this real quick. I want to take an example here because sometimes it can get a little tricky. If you're going, that seems pretty basic, it does. But one of the things, another difference between inequalities is when you put the variable on the other side, when you put the variable, we're used to the variable being on the left. When you put the variable on the right, with inequalities, you gotta be careful. All right, so that's why I wanted to take a look here. So this one is x is less than or equal to 2. So I'm going to go ahead and move this to 2. All right, now notice it has the equal, right? So what do I want? I want a closed circle. X is less than or equal to 2. There it is. All right, now I'm going to generate a new one. Okay, now this is why I wanted to come here. Notice now the variable is on the right, okay? So many times people say, well, greater than goes to the right and less than goes to the left, but that doesn't always work. So let's look at what this says. It says -5 is greater than x. So let me go ahead and move this to -5. So I've got that number there. Notice there is no equals, so I'm going to go ahead and make this an open circle. All right, and notice, even though that's a greater than symbol, it goes to the left. Because what does this say? It doesn't say x is greater than -5. If it said x is greater than -5, it would go to the right. It says -5 is greater than x. Okay, all this part over here in the red, oh, and I don't have a red. How unfortunate is that? All right, all this over here in the red, these represent the x's. These are the values, and what does it say? -5 has to be greater than them, right? So if I put something over here, like say I put 0, is -5 greater than 0? It's not, okay? So when the variable is on the right, greater than actually goes to the left. And when the variable is on the right, less than goes to the right. So it's kind of tricky, all right? So now we're back to having the variable on the right. So greater than is going to go to the right, all right? But we want x to be greater than or equal to 4, so I'm going to put it on 4. It's got that equal sign, so I'm going to go ahead and close it in, and there we go. All right, I want to do another one when we get the variable on the left. All right, this one. Excuse me, the variable on the right. 0 is greater than x. So I'm going to put this on 0. All right, I'm going to change it to an open circle. Now, what does it say? 0 has to be greater than x. Remember, everything that you're shading, this arrow part, represents x. Well, if you look at what's there right now, what does this say? This says 0 is less than x. All of these values are bigger than 0. But I want 0 to be greater than all those values. So what do I have to do? I have to turn this the other direction. Okay, so be very careful which side the variable is on when you're making your graphs, because that's going to flip the direction that you go. All right, so you cannot always say greater than goes to the right, and you cannot always say less than goes to the left. It doesn't work that way. Okay, all right, so let's go back to the textbook, because we actually want to not just graph them or write them, we want to solve them just like we solved equations. Now, if you remember, when we solved equations, we used inverse operations, and whatever we did it to both sides, okay? So if we take a look here, we've got 2 is greater than or equal to -3. Do you agree that that is a true statement? I hope you do. Now it says to add 3 to both sides. All right, so what am I going to have? On this side, I'm going to have 2 plus 3. And I want to know, is that greater than or equal to -3 plus 3? Well, when I do that, what do I get? I get 5 is greater than or equal to 0. Well, that is also true. So I added 3 to both sides, and it stayed true. All right, -1 is less than 6. That's true. Do you agree? Now they want us to add -1 to both sides. Well, -1 plus -1, that makes -2. All right, -2 is less than or equal to, let's try this, 6 plus -1. And again, I'm going to put a question mark because we're not sure if it's going to be true. -2 is less than or equal to 5. Well, that is also still true. So I added 3 to both sides, it stayed true. I added -1 to both sides. By the way, adding a -1 is the same as subtracting a +1. All right, and I'm just going to tell you now, if I subtracted 8 from both sides, I'll just do it real quickly mentally. -8 minus 8, that's going to be -16, is greater than -10 minus 8, that's going to be -18. That is still true. All right, so adding or subtracting, whether you add or subtract a positive value, does not change whether your inequality is true or false. Okay, so adding and subtracting is just like with equations. You could add or subtract whatever you want to both sides and it stays true. So we can work with those inverse operations and we can be convinced that what we started with, if it was true, what we finished with will also be true. What about multiplying and dividing? Okay, what about if we multiply? So we've got here a true inequality. All right, I'm just going to let you know all of these inequalities we're starting with are true. All right, 4 is less than 8. Divide both sides by 4. All right, so 4 divided by 4, is that going to be less than or equal to 8 divided by 4? And I get 1 is less than 2. That is true. So I divided by a +4, it stayed true. All right, what about if I divide by 3? Okay, in fact, you know what? I'm going to do something different here. I'm going to multiply, all right, because I want to show that you can multiply or divide. So if I multiply by 3, 12 times 3, is that greater than or equal to, and again, I'm going to slip my little question mark in there, 12 times 3 is greater than or equal to -15 times 3. Well, 12 times 3 is 36, is greater than or equal to -45. That is also true. So when I divided by 4, stayed true. When I multiplied by 3, stayed true. What about if I divide by -4? All right, so probably thinking, come on, Mr. Reeves, they're all staying true. Just tell us they all stay true. -16 divided by -4, is that indeed less than or equal to 12 divided by -4? Well, -16 divided by -4 is 4, is less than or equal to question mark 12 divided by -4 is -3. Is 4 less than or equal to -3? No, that is false. I divided by a negative and it went from being true, -16 is less than +12, to false. Multiplying by a negative made my inequality false when it started as true. What about multiplying? I'm sorry, that was dividing by a negative. That took my inequality that was true and made it false. What about multiplying by a negative? What about if I do 15 times -5? All right, is greater than, again, question mark, is this true? Is it greater than 5 times -5? All right, well, 15 times -5 is -75. Is -75 greater than -25? Well, 75 is greater than 25, but -75 is much, much smaller. It's 3 times smaller. So this is also false. All right, so something weird has happened here. When we added or subtracted anything we wanted to, if it was true, it stayed true. When we multiplied or divided by a positive number, if it was true, it stayed true. But when we multiplied or divided by a negative number, it went from true to false. So what do you notice when you divide both sides of an inequality by the same negative number or by a negative number? It goes from being true to being false. So that is going to affect how we solve inequalities. All right, so let's go over here to one-step inequality. Solving one step, again, there's our symbols. There's greater than or equal to, less than or equal to. And they're using the word here on Khan Academy, evaluating inequalities. I really wish they would have said solving inequalities. Remember, solving an equation was finding the value of the variable that made the equation true. All right, we are now trying to find the value of the variable that makes the inequality true. So we've got x plus 7 is greater than 4. Now, if I had x plus 7 was equal to 4, what would I do? I would subtract 7 from both sides. We're going to do the same thing with an inequality. Remember, we showed that adding or subtracting did not change whether an inequality stayed true or not. If it was true, it stayed true. All right, so the inverse of adding 7, subtracting 7, we get x is greater than -3. By the way, you will be asked not only to solve them, but you will be asked to graph them as well. I just want to remind you what that would look like. So on my number line here, all right, I always put 0 on my number line. All right, and then I'm going to go 1, 2, 3. Here's -3. I want x to be greater than -3, so I would put an open circle, and then I would put an arrow going to the right from there. All right, we want one without there. There we go. I think this will do it. All right, just like that. You know, we better make it a little bigger if we want to see it on there. Let me try this again and go all the way to the end. There we go. We could see a little better. All right, so that would be x is greater than -3, and that would be your answer. All right. All right, what about this next one? Z minus 11 is less than or equal to 5. Well, what's the inverse of subtracting 11? It's adding 11. So when we add 11 to both sides, we get z is less than or equal to 16. Z is less than or equal to 16. So again, you will be asked not just to solve them, but to graph them. So there we go. Again, I always put 0 on my number line. All right, so I'm going to put 0 here, and then way over here, I'm going to put 16. All right, notice it's less than or equal to, so that's going to be a closed circle. All right, so here we go now. This time we want an arrow that's going to go this way, and this time we do want that closed circle on there. So I'm going to start here. Oops, that wasn't what I wanted, was it? All right, let me try. Let me try this one. Start here and go that way. All righty. And there is my graph of x is less than or equal to 16. Notice it is a colored in circle. It's a solid circle because all of these numbers here are less than 16, but 16 is equal to itself. All right? All right, so this one right here, if I wanted x minus 8 is less than -1, what would I do? I would add 8 to both sides because that is the inverse operation. And when I did that, I would get x is less than 7. X is less than 7. So x is less than, so nice of them to give us that symbol, so nice of me to use it twice. X is less than, come on, Mr. Reeves, you can do this, 7. All right, can we put that answer in? Next question, what about this one right here? All right, -9 plus x is less than or equal to 4. Well, what am I going to do? I'm going to add 9 to both sides, and when I do that, I get x is less than or equal to 13. X is less than or equal to 13. So x, there is our less than or equal to symbol, 13. There we go. Ka-chow. All right, so those were one step with addition and subtraction. No problem. It's just like solving equations. There really is no difference with adding and subtracting between inequalities and equations, except instead of equals, you have either greater than or equal to, or less than or equal to, and many times you're going to be asked to graph them. All right, but what about with multiplication and division? All right, so they have an example here. 10x is less than or equal to -3. So what did they do? They divided both sides by 10. Now, this is very important. They are dividing by a positive number. When you divide or multiply by a positive number, it does not change the truth value of the inequality. If it started true, it stayed true. So if this inequality is true, then this inequality is also true because what did we do? We divided by a positive number. Let me say that again. This is so important. Multiplying and dividing by a positive number does not change the truth value. If it was originally true, it stays true, or it doesn't change the truthfulness of the inequality is another way to say it. All right? But if you take a look at this next one, all right, we've got y divided by -6 is greater than or equal to 4. Well, what's the inverse of dividing? It's multiplying. So what did they do here? They multiplied by what? I wish they had not used that x for multiplication. All right, they really should have used a dot. This should be a dot. All right, or parentheses. We don't use x's for multiplication when we're doing algebra. All right? Okay, so I multiplied by -6. When you multiply by a negative, it does change the truth value or the truthfulness. If this is true, this is now false. All right? By multiplying by a negative, you took something that was true and you made it false. So how do we fix that? We know we have to multiply by -6 because that's our what? That's our inverse operation. We're still going to use inverse operations. We have to do it, but we just made it false. So let me ask you a question. If it's not greater than or equal to, what's the opposite of that? How about less than or equal to? Because the equal to part doesn't matter. We can multiply or divide, and that doesn't change the truth value or the truthfulness with an equation. But the greater than, the opposite of that is less than. All right? So if I have 2 less than 3, that's true, right? If I multiply both sides by -1, right, I have now made it false. So how do I make it true? I simply flip that around. I make it greater than, and I get -2 is greater than -3, and now it's true. So what do you do to take a false inequality and make it true? You flip the inequality sign. What do you do to make a false inequality true? You flip the inequality sign. All right, so that's what I need to do. Notice, all right, it was greater than or equal to. Now it's less than or equal to. Whoa, why did the symbol change? All right, Mr. Reeves just explained why the symbol changed. So when you multiply or divide as part of solving an inequality, you must reverse the inequality sign because that multiplication or division makes it false. By flipping that inequality sign or reversing that inequality sign, you're making it true all over again. Okay? All right, so if we take a look at this one, 2x is less than 15. What would I have to do? I'd have to divide both sides by 2. X is less than 7.5. The inequality was true, and it stayed true because I divided by what? I divided by a positive number. So our answer that we get is x is greater than 7.5, or if you wanted to put the answer in as a fraction, you could put 15/2. All right. Oh, Mr. Reeves, I accidentally changed the inequality sign. Oops. All right, that's why it's nice to have something that's self-checking. We can catch those errors. I did not mean to reverse it. We divided by +2. I need to listen to my own teaching, huh? All right, how about the next question? Here we go. X divided by 7 is greater than -2. All right, so what am I going to have to do on this one? I'm going to have to multiply by 7. Now, what kind of number am I multiplying by? A positive number. So that means if it started true, it's still true. So what do I get? I get x is greater than -14. I don't need to change the inequality sign because I multiplied by a positive number. Yes, that 2 is negative, but that's not what I multiplied by. I multiplied by a positive 7. Let's see if I can get it right this time. All right, how about we say that x is greater than, because it did not change. What was it? Negative 14 was the answer we were looking for. All right. Now, what do we have to do on this one? Here we go. This one, it's negative 6 times x is greater than or equal to negative 20. I'm going to divide by negative 6. What am I doing to solve this? I am dividing by a negative, which means my original one was true, and now I have just made it false. So how do I make it true? By changing, by flipping, by reversing the inequality sign. So instead of x being greater than or equal to, x is less than or equal to, and I get a negative 20 divided by a negative 6, which simplifies. If I divide both of those by 2, if I divide both of those by negative 2, I get 10/3. Notice it doesn't go in evenly, and I don't want to make that a decimal because it would be a non-terminating decimal. So the answer is x, but not greater than. Now it is less than or equal to, and what do we want on the top? We want 10, and on the bottom we want 3. All right, greater than or equal to. Whoops, could have swore I switched it. Didn't I switch it? It went from greater than or equal to. You did switch it, Mr. Reeves. All right, I don't know why I'm seeing backwards here. There we go. Okay. All right. So, ladies and gentlemen, that is how you recognize and solve inequalities. All right, in my next video, I will go through and do a bunch of practice problems with you. Until then, have a great day. Bye.